us look at parabolas. Parabolas are most definitely functions. So if we look here at the standard form of a parabola, which is y equal to ax squared plus bx plus c. These values, the b and the c, if we ignore that and we only look at this term here, what we must notice is that the x squared is greater or equal to 0 for all x values. The only value that can influence the sign of, let us call this number 1, is the value of a. If a is positive, then ax squared is also positive. And if a is negative, then ax squared is negative. Because we know that that is greater or equal to 0. So this is something that we have to take into account when we do parabolas. Why do I say let's ignore the b and the c first? When we look at big numbers for x, then the bigger the x become globally, the b and the c have little influence on the value of y, where y is equal to ax squared plus bx plus c. If we look from very far off, that's why we say globally, then that is approximately ax squared. But locally, the bx plus c will give us the interesting detail of such a parabola. So in this video, we only consider values of a positive and negative. We do not look at b or c at all. So in this video, we take b equal to 0 and c equal to 0. And then we look at different cases. In this video, we're going to consider only x values minus 1, 0, and 1 and compare three functions at that three different x values. Initially, to find the form of a parabola, you have to set up a table with many x values, including, for instance, negative a half, negative a quarter, negative 1/8, etc., to see all the different, or how the shape of a parabola will be. So, but in our case, we assume that you already know that the parabola is what the form of a parabola is. So if we take the function value, we see that a in this case is 1, because there's a 1 x squared there. It's 1, so a is positive. If I plug in this minus 1 into that formula, then I have minus 1 squared, and that will give me plus 1. If I plug 0 in there, then I get 0, and if I plug 1 in there, I get the answer of 1. So when I then show those points on the graph, then I will have a parabola that's going through the points x minus 1, y plus 1, x plus 1, y plus 1. In our table, I'm going to make it smaller. In our table, we had that values. Okay, and the point here in the middle, the 0, that's the origin. X is 0, y is 0. X is negative 1, y is plus 1. That is point A. X is 1, y is 1. That is point B. So this is our point A, this is our origin, and this is our point B. We can write down the coordinates: A minus 1, 1, 0, 0, and b plus 1 plus 1. I like to call this my mother graph. So whenever you want to draw another parabola, you know at least this is how the shape should look like. So let us see what happens if we change the value of a. In this table, I've repeated the first function, f of x equal to x squared. I've just filled it in here. If I now have g of x equal to 2 times x squared, then if I compute that value, I get minus 1 squared, and that will give me plus 2. And this will again be 2 times 0 squared, that's equal to 0, and 2 times 1 squared, that is equal to 2. So here we had the point A, minus 1, 1. There we had the origin. And here we had the point B, 1, 1. In this case, we have the point C. X is minus 1, y is 2. Still O, the origin, and then also point D, which will be now x is equal to 1 and y is equal to 2. So this is what we computed there. So let us look at the graphs. So when we make the A bigger, what happens here is I've plotted the point C and D there. What happens here is this red graph, the green graph is the mother graph. The green graph grows faster. So what happened now at minus 1, 1 is now at minus 1, 2. And what happened at 1, 1 is now at 1, 2. So each value on this green mother graph, if I take a value there, then I can multiply by 2. So if A is larger than 1, then the parabola resulting from that is narrower because it grows faster than the green graph, the mother graph. I've again repeated the values for F and for G. And now we're going to compute for H. So if we take H, we take a half times minus 1 squared, then we get plus a half. If we take 0, then we get 0. And if we take a half times 1 squared, then we get a half. In this case, here we had the coordinates of A. For all of this, it is the origin. And here we had the point B. Here we had C. Here we had C. X is negative 1, y is equal to 2. Here we have D. X is 1 and y is equal to 2. So in this case, my A, B, C, D, E is again x is negative 1, y is plus a half. Again we have the origin, and again we have F, which is at plus 1 and a half. So in the next diagram, or next graph, I've just plotted that, all those values there. So again, there's our mother graph, our A and B, the green graph. And the C, D, this is where we had y equal to 2x squared. And now, the blue graph here, it is much wider. It grows slower than the mother graph, much slower. So when the mother graph is already at y equal to 1, that's still at a half, etc. And so when x is equal to negative 2, that will only be at 2